I am Anil Kumar. Welcome to my series on complex numbers. Here's a worksheet to practice division. There are 7 questions. I'd like you to pause the video, copy these questions, solve, and then look into my suggestions. All the questions basically involve one particular process which we call realization. So, which is similar to rationalization. So, it is realization. How do we do this? If we know that a complex number z is equal to, let us say, x plus iy, then the conjugate of z can be written as x minus iy, right? And the product of the complex number z with its conjugate is what? Let's multiply and check it out. It is x plus iy times x minus iy. So when you multiply, you get x squared minus xy. This gives you plus ixy, and that gives you minus I square y square. Now I square is -1, and these two terms here cancel out. So what we get here is x square plus y square. So what you notice here is that the product of z with its conjugate is real. Number. And therefore, this process is called realization. Now what we are going to do here is, in all these questions, whatever is the denominator, we are going to multiply and divide by the conjugate of that to get it a real number in the denominator, and then we'll find equivalent complex number in the form of a plus ib or a plus bi. So I hope this process is absolutely clear. Another important thing to remember is that two complex numbers are equal. So when I say equal complex numbers, means what? It means that real parts are equal and imaginary parts are equal. Now that helps to really solve the questions which are listed here. Now this set also includes how to find square of a complex number and use similar process to find square root of a complex number. So let's begin by solving these questions one by one. Here is question number 1. We are given that a plus ib is equals to 1 over x plus iy. You need to find a and b. Right? So let's begin with the right side. So, or we can just write like this. A plus ib is equal to 1 over x plus iy. Correct. So what we are going to do here is we are going to multiply and divide by the conjugate. So we'll get 1 over x plus iy times x minus iy over x minus iy. Right. So in the very first step, we did the process of realization. Right. So as we had seen earlier, we get x minus iy in the numerator, and the denominator will be x square plus y square, correct? This is what I had shown you right in the beginning. So instead of doing all the steps, which are these steps, I'm writing the final statement, which is x square plus y square. Perfect. So I hope that is clear. Now we can from here write down this in two parts, which is x over x square plus y square minus iy over x square plus y square. Clear? So now you can compare these two complex numbers, a plus ib, and the one given here will be equal only if a is equal to x over x square plus y square and b is equal to negative of y over x square plus y square. Is that clear to you? So that is how we can find the value of a and b. Perfect. Now let's take question number 2. Question number 2 is very similar to what just we did. So you can actually follow the same process. The only thing is we are given not a general form. So we can now write this as 1 over 2 plus 3i can be written as equal to 1 over 2 plus 3i. We'll realize it, that is to multiply by its conjugate, which is 2 minus 3i, divided by 2 minus 3i, correct? And that gives you 2 minus 3i over, here we get 2 square plus 3 square, right? So we get 2 square plus 3 square, which is 2 minus 3i over 4 plus 9, 3 square, 4 plus 9. Or we can write this as 2 over 13 minus 3 over 13i. So if you want to make it equal to a plus ib, so that clearly indicates that a is equal to 2 over 13 and b is negative 3 over 13. Is that clear? Perfect. The next example here is, in the numerator this time we have 2i, right? It's not just a number, right? Not a real number. So the numerator here is imaginary. Let's see how to do this. So 2i over 3 minus 2i, will realize it multiplying by 3 plus 2i over 3 plus 2i, correct? So that gives you, when you multiply the numerator, 3 times 2 is 6, we get 6i, minus 2 times 2 is 4, I square, right? So I square is negative, so we get minus 4. Perfect. Over the denominator is 3 square plus 2 square. So what we get here is 6 over 9 plus 4 is 13, I minus 4 over 13. Is that clear? Now if we want to find what is a plus ib equals to, or sometimes you write bi, let's rearrange. We'll see this is minus 4 over 13 plus 6 over 13i, right? So clearly we know what a is equal to. A is equal to minus 4 over 13 and b is equal to 6 over 13. So you see the difference now? Since we have a complex part in the numerator, it got kind of different from what we started with. Here is another variation. And this time we have square in the denominator. So let's work with this complex number 1 plus 3i whole square. So we'll just expand the denominator, keeping numerator as 1. So what we get here is 1 plus 6i square of 3i square. So let me write plus 3i square. Okay. So that gives you 1 over 1 plus 6i, and this is 9i square with a negative sign now since I square is negative, so minus 9. So what we get here is 1 over 6i minus 8. Okay? So 1 over 6i minus 8 is our denominator. Okay. Let us realize this. Let me realize this. So we have 1 over, let me rewrite this as minus 8 plus 6i. To realize, we'll multiply and divide by the conjugate of denominator, which is minus 8 minus 6i over minus 8 minus 6i. Correct? So the numerator is minus 8 minus 6i, and the denominator is, when you multiply minus 8 with minus 8, you get 64. Multiplying minus 8 by minus 6i gives you plus 48i. Now with 6i, we get minus 48i, right? So they cancel, correct? And then plus and minus gives you negative 6i square, correct? So these two terms cancel, and what we get here is minus 8 minus 6i over 64, that is the square of 8, and this minus becomes positive I1, right? So the sign changes, so we have plus 36 here. Perfect. So what we get here is minus 8 over 100, and then we get minus 6 over 100 I, right? You could simplify this, dividing them both by, simplifying rather, right? So you can divide this by 4, right? So you get minus 2 over 25, and dividing this by 2, you get minus 3 over 50 I. So that is how you could write your complex number, and we can write down our answer that A is equal to minus 2 over 25 and B is equal to minus 3 over 50. Is that clear to you? Right. So there is a variation. So when there is square in the denominator, you should note how the things change. Now here's another example. This time we have complex number in both numerator and denominator. I would like you to pause the video, answer this question, and then look into my suggestions. Now let us see how to solve this question. On the right hand side, we are given 4 minus 2i over 1 plus 2i. Now we will realize this, that is, we'll multiply and divide by the conjugate of the denominator, which is 1 plus 2i, conjugate is 1 minus 2i, correct? So let's multiply the numerators. You get 4 times 1 as 4 minus 8i, and with minus 2i we get minus 2i, and that becomes 4. Minus minus is positive, but I squared is negative, so we get minus 4 here. The denominator will be 1 square plus 2 squares, which is 4. Correct? Now that can be written as 4 minus 4 is 0, and we get minus 10i over 5. And this can be written as minus 2y. Perfect. Now, what we are given here is that a plus ib or bi is equals to minus 2y. So that really means that the value of a, the real part is 0 here, right? So a is 0 and b is equals to minus 2. Is that clear to you? So that is going to be the answer for question number 5. Now let's take question number 6, where we are saying 3 minus 4i is equals to a plus bi whole square. We need to find the value of a and b. Right? So we have 3 minus 4i is equal to a plus bi whole square. So let's expand this. So what we get here is a square plus 2abi minus b square, right? Because I square is, or you could go do it in two steps, bi whole square, right? So we can write this as 3 minus 4i is equal to a square plus 2abi and this minus 1, right, b square, which is same as a square minus b square. So these are the real parts and the imaginary part is 2abi. Now since this is equals to 3 minus 4i, we get two equations here. One of the equation is 3 is equals to a square minus b square. So we can write 3 equals to a square minus b square. The other equation is minus 4 is equal to 2ab. Correct? So these are the two equations to solve. Now we can write one in terms of the other using the second equation. So let's say b is equals to, so from here we get b equals to minus, when you divide 4 by 2 you get 2 over a. So that's the value of b. So we are going to use these two equations, that is the equation number 1 and this is equation number 2. Substitute b in equation number 1 and then solve. Right. So that's what we are going to do. We'll have a quadratic equation when we substitute. So we get 3 equals to a square minus, so instead of b we are adding minus 2 over a whole square. So we'll solve this equation. Perfect. So we have 3 equals to a square minus 4 over a square. Multiply by a square, we get 3a square equals to a to the power of 4 minus 4. Bringing the terms together, we get a to the power of 4 minus 3a square minus 4 equals to 0. Now that can be factored and we can write this as a square minus 4 times a square plus 1 equals to 0. So that gives you a couple of solutions. So a square minus 4 means we have one solution here, which is a square minus 4 means that a could be equal to plus or minus 2, right? Now a square plus 1 is no real solutions, right? So this is no real solution. Perfect. But that gives you two real solutions. This gives you a equals to plus minus 2. So for two different values of a, we do get two different values of b. So we could write this as if a equals to 2, in that case b is equal to minus 2 over 2, which is minus 1. And if a equals to minus 2, b is equals to minus 2 over minus 2, which is plus 1. Correct? So we can write down that 3 minus 4i is indeed equal to, let's take the value of a as 2, b as minus 1. So we get 2 minus I whole square, which is same as also writing minus 2 plus I whole square. Right? Both are one and the same things. Correct? So that is how you could actually write down your answer. Okay. So we do get the value of a and b. So we'll write the values. There are two solutions to this. So the value of a could be 2. In that case, b is equals to minus 1. And if a is minus 2, then b is equals to plus 1. Now in this case, you should also make a note that which we are going to use in the next example, that square root of 3 minus 4i is equal to 2 minus I. Does it make sense to you, right? So square root of 3 minus 4i is 2 minus I. Perfect. So that is another important thing which we learn in example number 6. Here is the last question for you. I'd like you to pause the video, answer this question, and then look into my suggestions. The question here is, find square root of minus 5 minus 12i. So let's say let a plus bi be equal to square root of minus 5 minus 12i. In that case, square of a plus bi should be equal to minus 5 minus 12i, correct? So we can just expand the left hand side, which we get this as a square plus 2 abi plus b square, which is I square becomes negative, so we get minus b square, right? Equals to minus 5 minus 12i. Let's rearrange. So we get a square minus b square. This is the real part, plus 2 abi equals to minus 5 minus 12i. So that gives you two different equations, right? So the two complex numbers are equal when we equate real parts corresponding real and imaginary parts, right? So we get two different equations. We'll solve these equations and then find the square root of the given complex number. So from here, the real part is minus 5 and here a square minus b square. So we get a square minus b square equals to minus 5. The second equation is 2abi is minus 12i. That means 2ab equals to minus 12. So we can write one in terms of the other. We can write a is equal to minus 12 over 2b. That gives you the value of a as minus 6 over b. So we'll substitute this value in our equation, right? So we'll substitute this value of a here. So what we get here is minus 6 over b whole square minus b square equals to minus 5, which is 36 over b square minus b square equals to minus 5. Now we can cross multiply, write down our equation and then solve. So we get 36 minus b to the power of 4 equals to minus 5b square. Correct? So that becomes quadratic equation which we can solve by factoring. Let's bring all the terms together to the right hand side. So we get b to the power of 4 minus 5b squared minus 36 equals to 0. Right? To factor this, we are looking for two numbers whose product could be 36 and sum as minus 5. So that could be 9 times 4, right? So 9 times 4 can work for us. So we get b squared minus 9 times b squared plus 4 equals to 0. Now that gives you two solutions, and which gives you the solution as b equals to plus minus 3. So we have two solutions for b. So if b equals to 3, in that case a is equal to minus 12 over 2 times 3, which is minus 2. Right? And if b equals to minus 3, then a is equal to minus 12 over 2 times minus 3, which is positive 2. Right? So that becomes our solution. So we do have square root, and the square root of this number can be written as the value of a is minus 2 for b as 3. So we could use any one of these. So we can write down that the square root of minus 5 minus 12i is equal to minus 2 plus 3i, right? We could write like this: the square root of this number is minus 2 plus 3i, or it is also equals to, when we use b as minus 3, then a is 2. So we get 2 minus 3i. So that becomes the solution for the given question. I hope that makes sense. With this, we come to an end of our worksheet on how to divide with complex numbers. The idea here is to make the denominator as the real part. And this process of making denominator as the real part is also called realization. It is very similar to rationalization, which we've done for rational functions. So the concept realization helps to divide the complex numbers. In this process, we also learn how to find square of a complex number and how to find square root of a complex number. I hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.